Hey guys. I think we can all agree that the last video I did was way too long, so I'm going to try to be a little bit more to the point, which I think I say that all the time, but anyway, we'll just move on. I also feel like I need a bigger whiteboard, but we're going to do the best with what we have. So to keep the video brief, I'm only going to go over two of our problems. They're still from the section 1 PowerPoint, the first PowerPoint I posted last week. It is the first section of chapter 12, all about lines that intersect circles. We talked about the different types of lines that intersect circles on the last video. We are focusing on the first two theorems of the chapter, of the section, which talk about our tangent lines and that point of tangency where the tangent line intersects the radius. So slide 22 of the PowerPoint, just to reiterate that theorem I was talking about with the tangent, says that that point right there of tangency meets at a 90-degree angle, which we all know that means perpendicular, right? So the fact that we know that this tangent segment meets here with the radius at a 90-degree angle, we are going to form a right triangle. So we learned so much about right triangles this year and ways to solve measurements and missing pieces of information about right triangles. So once we've established using that theorem that we have a right triangle, we can solve these difficult word problems. So just bear with me. The answers and the work are all in the slides as well if you can't read this that well. But I've basically just put slide 22 on my whiteboard here. So it says Kilimanjaro is 19,340 feet tall. What is the distance from the summit to the horizon? You'll see a lot of horizon examples when we're talking about circles. So the circle is supposed to be Earth. C is represented as the center of Earth. They round the distance from the center of the Earth to the surface to 4,000 miles. That's given to you in the problem. And they tell you that Kilimanjaro is 19,340 feet tall. So I've drawn my little mountain right here. And the top of the mountain, the peak, I've labeled as E, just like the PowerPoint did. And then the base of the mountain at the surface of the Earth is labeled with a D. The point of tangency, so imagine you're standing on the top of the mountain at E, and you're looking off to the horizon. The horizon is where, as we know it, is when the sun is coming up or over the Earth. So if you imagine where the horizon is, you're at the top of the mountain and you're looking down at the surface of the Earth. So this is going to be that line of vision, that line of sight is going to be your tangent line that meets with your radius at a 90-degree angle. And the radius is the distance from the center of the Earth to the surface. Okay, so now that we have understand our image that's drawn and given to us in the PowerPoint, let's go ahead and plug in the missing pieces into the other geometry theorems that we know. And guess which theorem that is? The easiest one to use here is going to be the Pythagorean theorem. Kudos to all of you at home that said that. I miss you guys, by the way. I'm sure the majority of you don't miss math class, but I had really good students this year, so I'm thankful for you all. Already getting nervous about next year. Nothing to be nervous about. Okay, so we'll just kind of summarize the work that they do on PowerPoint slide 24. So they want us to give our answer to the nearest mile. So the first thing they did was they converted these feet into miles. And they want you to know, and you could have looked up if you wanted to, the fact that there are 5,280 feet in a mile. So if I have this many feet in a mile, how many miles do I have in the height of Kilimanjaro? So 19,340 divided by 5,280 is about 3.66 miles. Okay, so now I know with my Pythagorean theorem that leg squared plus leg squared equals hypotenuse squared. Hypotenuse is always directly across from the 90-degree angle, and it's always the longest of the three sides. So if I want to solve, I already know I'm given the length of this leg is 4,000 miles, and I want to know the length of any of either two. I don't know the length of this one, that's what they want me to solve, but I can find out the length of this one because I know if this radius is 4,000, what's the distance of segment CD going to be? All the radii in that circle are going to be 4,000 miles. So if I want to find the distance of EC, I'm going to add 4,000 to how many miles tall Kilimanjaro is, which is 3.66. So I do know the length of the hypotenuse, and I know the length of one of my legs of my right triangle. So let's plug that into our Pythagorean theorem of a squared plus b squared equals c squared. So we can say 4,000 is our a squared. We do not know our b squared, which is EH. We still have to solve that one. But we do know EC is going to be 4,000 plus 3.66. Okay, so now we just have to solve for EH. So what we're going to do is we're going to subtract this 4,000 squared. Just move it over to the other side. And get out my calculator, why not? Okay, so 4,000 3.66 squared minus 4,000 squared. Can you see that? Yeah, okay. Don't want a calculator error to be why we're getting this wrong. You get about 29,000. And what is your last step? I don't want to know what EH squared is. I want to know what EH is. So the opposite of the power of 2 is the square root, right? So I'm going to square root both sides. My calculator, I can just hit square root, and then I can plug in answer, my previous answer. I get 171. They want me to round to the nearest mile. It's 171.1, so I'm going to leave it as 171 miles. So the distance from the top of Kilimanjaro to the horizon is 171 miles. So if I was standing at the top of Kilimanjaro, I could see 171 miles in front of me. In case you ever wanted to know, right? Very good. If you have questions about that, comment below or send me a chat message. Okay, the last theorem in section 1 is, it's labeled 11-1-3 in your notes, and it's talking about, let me see if I can get it without a glare. Sorry, it's so bright. Okay, so you've got your circle. It's the one that says, looks like an ice cream cone, and it's the one that says if two segments are tangent to a circle from the same external point, then the segments are congruent. So I'm going to erase the Kilimanjaro example. Oh, that sounded bad. We're just going to talk about that for a second. Okay, so I have a circle. I have a random external point, and what that theorem says is from that external point, if I have tangent lines, that's supposed to be just intersecting the circle, these segments will be congruent. So from here to here and from here to here are going to be congruent if it's drawn well. So we're supposed to use that theorem to solve problems, and that one, the math's easier on that one. I want to go to the little lesson quiz, the last slide. So slide 32. Where'd all my markers? I even lose markers in this little my daughter's classroom. So last slide on that PowerPoint is slide 32. I want to use number 4, and it says, this is what it looks like. They've got J, they've got E, F, G, okay. Says segment FE and segment FG are tangent to circle F. Find the length of segment FG. So using that 12-1-3 theorem that tells us that the segments here are congruent, we can solve for X and then solve for the length of both of these segments. So if I know, based off that theorem, that this segment is congruent to this segment, how would I set up an equation to solve? That is the geometry part, is knowing the theorem and then setting up your own equation. And that is why geometry is different than algebra. We actually have to write our own little equations. Okay, so if I know these are congruent, I would call on somebody, one of you geniuses, to answer this for me, but I have to act like you here. I would set them equal to each other. Very good. Okay, so the theorem tells me that these two are equal. So I set them equal to each other, and I'm going to isolate X on one of the other sides, doesn't matter which side, to solve for it. So first I see I've got parentheses I have to get rid of. I'm going to distribute that to 6 plus 12x equals 14x minus 8. I'm going to move this 12x over to the right so I don't end up with any negatives. Next step, move the 8 over here by adding it to both sides. I end up with 2x equals 14. Last steps, divide, get that 2 off of there, x equals 7. They didn't ask me just to solve for x, they asked me for the length of FE. So now I need to do what? I need to plug that x value back into here. I could do it on either one because they're equal in length, but I do like the fact that that coefficient of 6 is smaller. So I'm going to go ahead and plug the 7 here. And I get 2 times 3 plus 42. Follow order of operations and simplify inside your parenthesis first. 2 times 45 is 90, which is your answer. Okay, so I hope I didn't go too fast, but I'm trying to keep this video under 15 minutes. I don't want to bore you guys, but I enjoy these videos, and I was going to ask, first of all, if there's questions on section 1 material, definitely comment or send me a chat or an email or a remind text. But I was going to ask everybody who's listening if you guys are interested in a weekly chat meeting through Teams. So I can video chat. I can start a video chat with our whole class. I would send you a little invitation. I would create and send an invite. And you guys would choose to accept it or not and then come and join in. If you guys are interested, would tentatively do like a Friday wrap-up chat for the week. So that way if you have questions about your weekly tasks, or if you simply just want to, if you're bored and you want to say hi and chat with your classmates, I can set that up for you guys. It'd be per period, so first, second, third, etc. You guys would each have your own individual chat. So if you're interested, reply to this thread, to this post on Teams, not on YouTube. I disabled that for obvious reasons, but and say yes or no, and if it's a yes, around what time, at least like morning or afternoon. I'm assuming you'd prefer afternoon, but give me a window of time that you would like, please. And if I don't get a lot of people, just say yes, and I won't even worry about it. But my daughters are doing some Zoom meetings with their teachers, and they like it. It's cute. Okay, and then I have a joke to wrap up. It's not a really good one. Don't get your hopes up. Okay, why didn't the 2 4s want any dinner? Because they already ate. All right, love you guys. Miss you. Bye.